Welcome, Jonathan, to the second episode of Data Minds. It's a podcast to get to know the people behind all the data projects that are going on in Belgium. First of all, I would like to say thanks for contacting me. You were interested to
You're
share
welcome.
your
Welcome.
experience.
Happy to be here.
Thank you very much. So as usual, I got a list of questions prepared, but make this as free as you want it to be. Just talk about the things that you think are interesting, that you want to share about your experience working with data for quite a while now, right?
Yeah.
So maybe let's begin there. Let's start with your personal story. What did you study? How did you roll into this world of data? And everything up to the creation of your company. So for those of you who don't know, Jonathan is the founder and CEO of RoboVision, one of the most well-known AI companies here in Belgium, right?
Yes.
Good. So yeah, let's start there. How did you get there?
Well, I was always interested in the true nature of who we are and what we do here. So more of a philosophical foundation. And by doing so, you end up by thinking on a deep level of who are we and why can we think? So what is intelligence and how can we understand our surroundings? And in doing so, I realized that the world of mathematics was key to that insight. So I decided to study applied physics, which is of course very mathematical, engineering, and to really dive deep into the world of AI, which was in the 90s. So there was not so much talk about AI. It was not yet hyped, but I strongly believe that especially with computer vision, everything related to image processing, there would be an era where this would be extremely important. And a few years ago, this era started. And I'm really happy that I'm there with a team and picking the low-hanging fruit right now, because there is a lot of low-hanging fruit, also high-hanging fruit. But my data component is everything visual, everything which is there, how to acquire it, how to process it, and how to get intelligence out of it. And my driver in life is really to understand why we are here. And I see my company and also my team also has a vehicle for intellectual insights. So
Okay.
I'm not purely there for the money and the business side of it. I truly think that what I do is extremely interesting from an intellectual point of view, and is world changing and is a key to innovating society for a better life for everyone, for my children, your children, and for everybody living on this planet.
Cool. That's a very nice vision. So. Before starting RoboVision, did you already work at other companies or?
No. I started with studying applied physics, but soon I realized that it was not exactly what I wanted, because it was extremely theoretical. So we learned a lot about Schrödinger and coefficient calculations and complicated equations. But what I wanted to learn was this interface between biology and how biology computes stuff. So I decided to go to the ETH Zurich, University of Zurich, which is regarded as the MIT of Europe. And at the time that I arrived there, 1999, they were just founding a new institute, the Institute of Neuroinformatics, which really was a very ambitious project to explore the boundaries of our brain and to see what engineers could learn from the computational processes in our brain. And one very interesting thing there is the pathway, the visual pathway, so how we observe things and how they are processed. And because observation is so, straightforward, if a cat looks at a mouse, we know that somewhere a mouse is the focus in the cat's brain. So they were like really analyzing these cat brains, downloading information from their Cortex Feed21, so how they observed mice. And actually in those kind of labs, the concept of deep learning was born, because what we as researchers then soon realized was that information was processed in a layered way, and that the deeper you got into the brain, the more abstract the concepts became. And in a way, the movement, which was, started by Andrew Ng and Fei-Fei Li about 2006, 2007, called Deep Learning, the first big ImageNet competitions, which were, won by Deep Learning, were a little bit later, but it was all inspired by biology in a way, because neural networks were there for a long time, but this combination of nonlinear processing, localized nonlinear processing, and the stacked way of doing it is very much inspired by how our brain works. And I mean, I was very inspired by computers and how calculation was done when I was a young boy. I mean, I was really programming games and so when I was 10
cool.
on a Mac, which was kind of hard because I had to program it in HyperTalk.
I've never even heard of that, HyperTalk.
Yeah, indeed.
Cool.
But in a way, this von Neumann machine, which was the classic paradigm in computation, it really infested unknowingly the brains of many young engineers, and they thought that computation could only be done by a processor in a way that you just process registers and that you use the data to and the instruction sets all in the memory to do it in a sequential way. And that led to the true belief that computational stuff was linear and was actually done sequentially, but that's absolutely not how it's done by the brain. So
that's true.
At some point, the GPU came into play.
Mm-hmm.
I think the first one that really started to leverage was Andrew Ng at the time, 2009 more or less. And this GPU was made for massively parallel operations.
Yeah.
And was very easy to use because people, this gaming market, this gaming ecosystem was a very healthy, very aggressive, competition-driven market. So all of these APIs and all of these instruction sets needed to be extremely handy to use to enable this market and to sell ultimately more GPUs. And at that point, they were actually misused for massive parallel operations. And that's how this whole disruption was born. First in academia, but because of these Silicon Valley giants needing a lot of smart people, it was absorbed by the Twitters, the Facebooks, the Googles of this planet. And there something really strange happened. There was a massive wave of open source
absolutely.
publishing with TensorFlow and so on. So it was fantastic what is happening still right now. There is just a Cambrian explosion in intelligence. I mean, it's really disruptive. And I see that one of your next questions is the hype. Of course, it's a hype. We yesterday had a meeting with Gartner, and you know Gartner of the hype cycle.
Of course.
So we're talking like, where are we now in the hype cycle?
Yeah.
But I mean, look at the internet. At some point, it was also a hype, but it lived up to its promises. Mobile was also a hype, but it lived to its promises. And the same with advanced AI. I mean, I also clearly want to state that the term AI is actually kind of a difficult to use term because it's too broad. It's very ill-defined, and it's there for many years. Since 1956, it was actually posed as an ambition of humanity by Professor McCarthy in Dartmouth College. So actually what I mean with this AI is most of all this advanced stuff that was created or actually being reused in a much more scalable and smart way in the last 10 years, and which is de facto deep learning.
Yeah. So and your company was based on that premise, right? On
Yes.
AI. So just from my understanding, when you do projects, you never look at things, or it's never relevant for you to look at things like more traditional machine learning techniques, like I need a logistic regression, or you do look.
Yeah, of course. I mean, otherwise we are hyping ourselves if we only talk about deep learning. To an extent, that is true, because I mean, we have this label of being the deep learning company of Benelux. But in a way, we were frustrated how we did our business in the past. And because it was very project-based, but we wanted to do the most difficult projects one after another. And the thing with those projects was that we needed our smartest people to be there for longer periods of time. I mean, Tim, my CTO, was in Mexico for 3 weeks because he needed tweak all the stuff and so on, that we realized that we could never scale ourselves to a multiple if we kept on doing business as usual, project based. So at some point we just took the collection of all the projects we've done historically, and we said, like, let's make a platform out of it where other people, integrators and resellers, are able just to configure our platform and generate intelligence. And this you cannot do with normal vision programming, heuristic programming, decision trees, thresholds, and so on. You can only do that with a revolutionary technology, which is deep learning. And we were very early on. We programmed the first frameworks in Theano. And
that's still around? Theano is still popular?
Well, it's still around, but it's discontinued. So it's not. There is no contribution. It's just now the last commit is something like 1.5 years or 2 years ago, I guess. Could be wrong, but
and that was a competitor to TensorFlow, or that
it was the predecessor of TensorFlow. So Theano came from. I mean, with Theano, Lasagna was also created. And this philosophy of easily configuring complicated neural networks was actually born in Ghent, on the campus where we are in ID Lab. People like Sander Dieleman were actually founders of the first wave of making these neural networks more easy to configure. And this Theano and Lasagna ended up in TensorFlow and in more general, more broadly supported frameworks.
And so that brings us to your company. You said you offer a platform where people they don't need to know the intrinsic details, they just configure it. Can you walk me through it? So if I'm a client, how would that work?
Well, the whole thing is that this advanced AI is at this moment quite complicated to configure. You have deep learning servers of 16 GPUs. You need the storage connected to it, very high-end storage, so not normal hard drives. You need specific topology. You need on the cloud. You need this Docker orchestration and everything. And our goal as a company is to make the lives of our customers more easy and to get this customer journey in a very compact way. This go to market. This typical. From an MVP to a product for our customers, to get it really compact and quick. So, and to do that, you need a customer journey. You need a platform that really enables you at each of these sub steps to get from your data lake to your product, to your inference, to your model, your intelligence, in a scalable way. So that starts with data curation. Many of our customers have thousands of images, and they need to curate it to be curated. So you need to go through quite some of them. So you need the tools to evaluate whether your labelers are not biased and doing their job well. Because if you have like 1,000 labelers, you cannot survey that as an engineer and know what goes wrong. But the quality of your final models is very much depending on your data curation. So it's extremely important that you prevent a garbage in, garbage out situation. And that is what we manage. Actually, we are the prevention team for garbage in. So this whole management of the labeling crowd, this whole surveillance of how people could be biased and so on. I mean, you can imagine that a woman is labeling some particular aesthetical data in another way as a man. Absolutely. But you need to know that. I mean, apart from the fact that we're different, men and women, we could also be different at looking at data. So, but not only men and women, but also cultural. So it's extremely important that the models that will really have an important role in the society of tomorrow are transparent, and that we know how they came to be.
And that's what you guys do. You follow up on all the labeling that happens before the data is thrown at the model, so you understand if there are some biases there.
But not only that, because that was only the start of my journey.
Sorry, continue.
The platform. If this data is labeled, at that point you can choose from our platform, from our model zoo, which label works best. You don't need to be a data scientist. You just click and you can just run a training session on a complicated piece of hardware or in the cloud, Google, Microsoft, our partners. Then you can just see the result. You can just test on new data or data that you put aside before the training session. You can test it, you can challenge it, you can redo it, you can repair it in case you notice that something's tricky going on and that there was some data badly labeled. And then you can also put it into production. So this whole train of starting from the image series or video series or X-ray data set or 3D data set, this whole journey is managed by our platform, which is an as a service platform. So you pay a fee for using that platform based on your consumption, based on how many machines you set, how complicated the models are. Yeah.
And so you take, if I understand well, and correct me if I'm wrong there, so you take care of everything from labeling the data, training the model, to actually running the model on new data coming in.
Well, to say that we take care of everything is wrong.
Okay.
The customer can decide, and in many cases, he has to deliver the expertise. So, for instance, in healthcare, we're not going to label complicated pathology.
Yeah,
we're not certified for that. Our
No.
platform is not certified for clinical studies. But we are enabling our customers to use our tooling to get from A to Z in a smooth sailing kind of way.
Okay, cool. And so you mentioned one sector there, healthcare, which benefit from AI. Can you name other sectors that in your experience are more, let's say, more suited for the current AI technologies?
Agriculture. So our global coverage is agriculture.
Okay.
We have machines in Japan, Australia, California, even in Canada and Brazil. And what happens there is that our customers want full flexibility on the type of stem cuttings, so parts of plants which start to grow again when you take them off the mother plant, and want to have full flexibility on any kind of plant breed that can be distinguished or can be selected with a robot and put into the soil.
Okay, so I'm going to ask a stupid question there, but let's take that use case as an example. So what you get as input is images of plants with their stems, and then your algorithm decides if it's right to be cut, or how does that
work? Well, it decides where the optimal location is, where the robot has to pick up the stem to put it into the soil. If it's
oh wow.
Yeah. So, but you can see it on the website. There are plenty of videos of that.
Cool.
So,
I'll put a link to the video then in the description. Then would be very nice. So agriculture, health, is there other industries that you see benefiting from this? Maybe manufacturing.
Manufacturing.
Of course.
Second pole in our verticals. Yeah. Manufacturing is an obvious choice because products are getting more and more into how could I say, varieties. If you buy a car, you can select all kind of options and so on. So that leads to all kinds of quality detection challenges.
Yes.
And also there, deep learning comes to play. So that's something where we also are heavily focused on, making partnerships, trying to get this coverage as global as in agriculture. And that's where the specific algorithms that are engineered by humans are always, how could I say, are not flexible enough for product varieties and so on and so on. So we solve a problem in the quality inspection in manufacturing, which is man-force. There are not enough software engineers to create all the algorithms to do the quality inspection of our new products.
Yeah. And do you see, in your experience, is it the deep learning algorithms, they outperform the let's say the more human engineered algorithms?
Yes.
Yeah.
Very significantly.
Yeah.
I mean significantly.
Yeah.
And it's also logical in a way because a human mind has to abstract the situation, but we're very limited in time to think about problems. as engineers, we have a natural tendency of simplifying situations because we don't want to have 204 features to manage, also in our thresholds and so on, because we don't want to spend years on a specific vision algorithm. So this is solved by deep learning because deep learning has virtually many years and decades to solve this thing. It can go through all these features. It can challenge them. It can choose one feature over another, and that's exactly what happens. So, the whole philosophy to think about complexity deeply changed with deep learning.
Okay.
And I'll explain you why. Because normally, if you have a problem, the more sensors you put on that problem, the more complicated it gets, because you have to understand all this sensorial information.
Yes.
For instance, in a normal camera, you have 3 channels, red, green, and blue, which is kind of similar in human brains. We also have this, or mammalian brains, we also have this sensitivity for these 3 colors. But if you look at a hyperspectral imaging, you have much more frequency bands.
Yeah, absolutely.
But as humans, we don't understand them,
No.
because we just think, oh, that's a bit reddish, but actually it's actually some frequency band which we have no affinity with. I mean, imagine that you can see electromagnetical waves.
Yeah.
It would be truly interesting because you could see interferences with metallic constructions in your construction. You would, after a while, you would understand why your cellular phone is not working, because you would correlate these things. But because we don't have the sensors, we're not used to that kind of interference, and we're only have to we know at some places in our house that it's just not working.
Yeah.
So deep learning has no problem with that. So the bigger the haystack, the better for deep learning, because it can just cherry pick those features that are needed to solve the problem. And that's a fundamental difference with the human mind, is that this technology has the potential to go further than human intelligence.
Yeah.
It's not yet there, to be clear, but it's in some cases already working better than the best specialists on Earth.
Yeah, and so maybe that's another important difference that you mentioned there is it's about finding or selecting features. In deep learning is the algorithm who finds the features itself, right? While in traditional machine learning, it's up to humans to come up with hypotheses like what could impact this. Well, maybe let's calculate a feature here.
You have to choose that you will use a support vector machine.
Exactly.
You have to choose whether to use random forest approach or hidden Markov modeling. But that is already a very biased choice. You understand? Maybe you're just wrong, or maybe you're lazy. So,
or I mean, and that's also reality in everywhere, is that maybe you just don't know enough deep down inside how these algorithms work to make a good decision, right? That's also reality. Yeah. Not everybody is a professor of data science before they do their first data science project, right? That's just reality. Yeah. What I also see a lot in companies is that they spend quite a lot of time, engineering time, and thus money on just feature building, right?
Yes.
I still think that's valuable. I'm not saying we should throw all of that away, but granted, if the deep learning approach works, you can save so much engineering time, right?
And it's what's happening right now. So if you go to an arbitrary conference, let's say telecommunications, so expertise in putting and building antennas for cellular phones.
Yeah.
What you see right now is that decades of research, decades of modeling based on some physics and some human intuition, how to build the model, is just thrown away by applying deep learning on data sets. And it must be frustrating for many of these researchers to just come to the realization that their work has been in vain to some extent.
Well, in vain, we found something better, right? I mean, that's how it goes with everything, right? Like a couple of years ago, Theano was still a thing. Now it's not a thing anymore, but it lives on within TensorFlow, and at least the logic of it apparently still lives on. So that I guess that's just life, right? One story I really like is that I follow a little bit the chess world. I'm not a good player at all, but the story I like there is that, well, the old chess engines were already beating the grandmasters, so that was nothing special there. But the real experts in chess found it very boring because they couldn't understand those engines. It was very non-intuitive. While now with the new deep learning chess engines from Google, what was it, DeepMind or something?
Yes,
yeah. Now all of a sudden, they do play in an intuitive way, like humans would play, but then only 10 times better.
Yes.
So now, like chess grandmasters are looking at how are they dealing with these and these openings, and humans are learning from how the machine.
Yes, exactly. And that's eye-opening. It's also in the AlphaGo documentary.
Yeah, AlphaGo. That was it.
That Sudol, the grandmaster, at some point became emotional because he saw the aesthetics of a genius. Movement on the table.
Yeah, it's pretty cool, right?
And that's to go back to my roots. That's the reason I'm in this field. You understand?
Cool.
Because we all know that family members or from the media, from the time that the human mind starts to degrade or decay, for instance with dementia or those kind of things, we're also losing connection to us to I almost said the soul, but I'm not religious. But I you know what I mean.
Yeah.
It's if you don't have this mirror of reflection, if you cannot reflect your memes in another human being and get the response to your memes, you have a less conscient interaction.
Absolutely.
I mean, with a chicken you have a less conscious interaction because you know that if you throw food, the chicken will start to eat the food. I mean, the true nature of human consciousness is strongly linked to our intelligence. You understand? And that's also related to one of the biggest questions in AI. Will there ever be a conscient AI? And that's the reason I do this stuff. One of the reasons.
And what do you think the answer is?
Well, I'm sure there will be a conscient AI engine, but it will not live in silicon probably. But I mean, it's also related to the fact if we could create artificial life. I mean, if at some point we can compile life and it can start to interact with us, then we'll be quite, how could I say, special.
So maybe that brings me to the next question I had on the paper. There is that clearly you are very positive and exciting about all the opportunities that of AI brings, and you're putting it in reality, which is very nice to see because, well, it's always nice to dream about possibilities, but what I like about your story is that you're a dreamer, but you're also a doer, right? You're like both feet on the ground, of actually working with clients, trying to make their products better, their solutions better.
Yes.
On the other side of the spectrum, there must also be people who are much more skeptical of AI.
Of course,
right?
it's healthy. It's healthy. It's how democracy works. It's how society is supposed to function at its best. It's by differing opinions. And
what do you see there as maybe one of the risks of AI or top risks? Are you concerned at all about?
Yes, I am. I mean, of course, I could also be very negative here, but it's just how you approach the reality of the potential of AI. Let's not call it AI as such. There is still a lot of potential to be executed. Of course, there are I mean, the militarization of AI is something extremely creepy. Because it's not only about the militarization of AI, it's about vulnerability. You understand?
Yeah. What creeps me out, and I don't know if you would call it AI or not, but if you see the latest videos of Boston Dynamics, where they have this robot and they can do flip-flops and they can run better than humans, they can jump, they can...
Yeah, but it's not AI. It's I mean, many of these systems are feed-forward intelligence and just simulation.
Sorry, so for me, but probably also for some of the audience, what do you mean with feed-forward systems? How is it different from AI?
It's very engineered by humans what works as a flip-flop, and I doubt that they have like 10,000 of Boston Dynamic dogs that just were destroying themselves before they had the good model. So probably some of the stuff has been done with reinforcement learning, but what I focus on in AI discussions is exactly the autonomous part, the fact that you can do and create stuff that you couldn't do as a human being analyzing the problem. Whether from speech analysis or algorithm design and inspection, quality inspection. What I just mean is that I'm mostly talking about this autonomy. And what you see in Boston Dynamics is at this moment not autonomous. It's just very coded by teams of engineers.
Yeah. How to do a flip flop? Well, you have to press your leg like that.
Indeed.
And so when you talk about autonomy, you talked about reinforcement learning, and that is, and correct me again if I'm wrong, that is the notion where you just give the machine a target and he will figure out himself how to get there. Right?
Unsupervised learning.
Yeah.
You don't have labeled data. You just have a system where the agent can test out failure and success.
Yeah, and all of the projects you do, are they all reinforcement learning?
No. They're mostly supervised learning, A to B mapping, because that works best in the industry. You can also come up with systems that are then 99.99%. And reinforcement learning is good, but industrial applications at this moment are fairly limited because of the fact that you need a lot of compute. And I can imagine autonomous driving, you have reinforcement learning, but it's not yet there.
Yeah, well, and I guess a prerequisite for that is that you need some kind of, I don't know how you want to call it, but a digital twin or something where you can simulate your environment, right? Yes. You can't do, well, if you're very rich, you can do reinforcement learning in the real world, but I guess it's much, much cheaper if you can do it in the digital world, right?
Yes.
Yeah, absolutely. So maybe that brings us to the next topic, because, well, you do AI, but you also do AI on GPUs, right? That's what you told earlier. Can you explain a bit, like, I can run TensorFlow on my laptop on a normal processor, right? So what's the difference there? What is the value that GPUs bring there?
The massive parallelism of your compute while training and while inferring the models. So a processor, as I told you earlier, is based on the von Neumann paradigm, where...
And can you explain that as well, maybe?
So a typical processor is a computational unit that takes instructions from the memory and data from the memory, called registers. So the very early programs that were there were all written in assembler, because there were no languages, like meta languages, where you could do the if then else stuff in a more structured way. And that was actually the movement of registers, like chunks of memory that you moved from one to another. And in that way, you force the system to be very sequential. You force your algorithm to be very sequential. With the GPU, you can calculate zillions of neurons at the same time. And that's what you need, because if a photon moves, propagates as an information wave through our brains, a lot of neurons are touched at the same moment, you understand? So you need this kind of dynamic calculations where a lot of stuff is updated at the same time. And in a way, the GPU is only intermediary towards the real goal of computation, that's the quantum computer. Because with the quantum computer, you even have less challenges of updating data at the same time. You can do it faster than the speed of light.
Okay. And well, I've read a bit about quantum computing, but is it really coming, you think? I guess it's still in a very experimental phase.
It's very experimental, but the power is so huge that we have to start fearing the encryption disaster that will come, because all of the keys that we now have, the 128-bit and 256-bit key systems, will be broken by quantum computing. Yeah,
I heard about that as well. There's also, I think, if I'm not mistaken, the CEO of Microsoft, Satya Nadella, he's a big believer of quantum computing, and he thinks that is the next big wave to come. You're waiting for that as well.
Well, I'm a physicist, so I was my very first book when I was 13 years old was the Schrödinger cat. So from that moment, it was actually not because of physics. It was just an inspiring cover where this cat was both alive and both dead. That I was like, I want to understand that stuff. And I still don't understand it. So.
I was about to ask, because I'm not a physicist at all, but I try to understand like the double slit experiment and like these YouTube videos that go around, and it just blows my mind every time I see it. Cool. But so let's take one step back into GPU programming, where it's reality today. I saw on LinkedIn or on your website that you're working with NVIDIA, and they ship like this big box to you, and then you put it in your rack. What's so special about that big NVIDIA machine?
Well, A lot about the GPU is the memory,
Mhm.
because you need like extremely fast memory to update these virtual neurons in an efficient way. So one way to do it is to limit the data pulses that you give your system. So it's called batches in deep learning, the batch size. But for many applications, for many advanced training sessions, you cannot simply reduce the batch size to limited amounts, because you need very big batch sizes to actually update these neurons in an efficient way.
Okay.
So what did NVIDIA do? They created an ultra fast GPU system which can be regarded as one big GPU, like the DGX2. So you have 16 times 32 gigabyte, and they're interconnected in many efficient ways with a system called NVLink, and they make sure that if you want to do a training efficiently, you can just give it a huge batch size. And these kind of things are needed, for instance, for autonomous driving. So if you look at the company Tenuity, for instance, a Volvo joint venture, focused on autonomous driving, those kind of companies are buying such systems one after another, because the only way to combine all this LiDAR, thermal and 3D information and visual information of their test driving vehicles is with systems that have huge amount of memory. Yeah. And in such a way they can create bigger batch sizes.
Yeah, I see. And is that also what makes it different from what the cloud offerings are having? Because Amazon, Google, and Microsoft are all offering something similar, in my view.
Well, they are at this point in time, the cloud offerings are much more siloed. They are like offering you collections of GPUs, but the interconnects are not as fast as a DGX2 system. You have companies that just offer the DGX2 in their backend, but if you have a 16 GPU system of Amazon, then it's not so fast as a DGX2. We have benchmarked it because of the interconnects, because of the things. I mean, cloud companies need to be very efficient, so cost efficient as well. They have to think about power. They have to think about all kinds of issues that if you are high end, you're not so bothered with. You understand? You just want your deep learning model to be top notch, and you're ready to make the investment.
The hardware cost is not a main driving factor for you. You just need to solve the problem at hand.
Yes, because it only starts there. The story. I mean, you have these DGX2s. I mean, which is the most high-end one in the NVIDIA gamma, but then you can interconnect them with lots of DGX2s, and then you need ultra-fast storage to get your data in a fast way to your deep learning system, which is updating its weights each time. So you have all kind of next-level architectures challenges that need to be solved. You need InfiniBand routers, extremely fast routers, and you need extremely fast storage to provide this data. So the typical ecosystem which is being created to solve these challenging problems is very interesting also.
And can you, I don't know if this is public information, but if I want to buy such a system, I like it, what are the prices we're talking about here?
You have to, DGX2 is 360,000 euros, and then you also need support.
And that's for the box that you received in your...
Wow. Yeah. DGX1 is about 140,000 euros.
So it's really targeted at the high-end use cases.
Not necessarily, because fairly small teams are also buying our systems. It's just depending on your business needs. So, I mean, a car is also quite costly, and everybody's using cars. I mean, unfortunately.
No, that is true. Especially if you look at manufacturing, they're used to buying huge machines which cost millions, and then if you say, well, I need this GPU powerhouse of 360K, probably doesn't really is flagged as out of the ordinary, I guess, if you get the value out, right?
Yes.
Absolutely. All right, and then. Maybe one other concept I heard a lot about, but again, I'm not an AI specialist, is that Google launched these TPUs.
Yes.
Is that something different from GPUs, and how are they different?
Well, they are dedicated systems for deep learning, meaning if you look at the possibilities how to train networks, the most inefficient way is the normal CPU, single core CPU. Then you go to multi-core. The Xeon processors of Intel are already quite powerful in getting deep learning to work, I mean, in an efficient way. And then you go to the GPU, which is of course the powerhouse for deep learning. And depending on the use case, as we call it, you can have edge compute, or you can have the necessity to calculate deep learning models on the edge, really, for instance, in the street where a camera is just pointed at the crowd.
Because you can't upload all that data and then it's too slow.
That's what we call embedded deep learning. So in embedded deep learning, there are plenty of possibilities. You have the ASICs provided by the big Silicon Valley companies. Intel is providing Movidius. NVIDIA is providing Xavier, the Jetson TX2, TK1, TX1, and so on. And then you have ASICs. And ASICs are actually, I said already FPGAs,
No, you didn't mention that word yet, so maybe we can start there.
Then you have the FPGA providers, Intel and Xilinx.
And what's an FPGA?
It's a field programmable gate array. So it's actually a network of connections that you can configure in such a way that it actually can mimic the real-time flow of information go through a neural network.
Oh, wow.
So it's actually meant for low power quasi real-time applications, and it's programmed in a language called VHDL. And actually there is quite a renowned party not so far from here, E6, Ramses Valvicus, maybe you know them. They're a top expert in the world in FPGA programming.
And they're called E6.
E6, yeah. I will give you the link.
Yeah, cool.
And they try to box together with us orchestration systems where this kind of generation of models for embedded devices are much more easy than to start programming yourself. You understand? So our platform will be a hub between on-prem, cloud, embedded, and so on. So you just focus on the core thing, which is getting intelligence out of your data, and then you are in the midst of opportunities. You can just derive an embedded model from it. You can send it to the cloud. This is ready, like on-prem and cloud we already cover, but the embedded things like FPGA generation of VHDL is something we work out with partners such as E6.
Cool. All right. Maybe that brings us to the future of this field. How do you see this evolving? Well, anything between here and let's say the quantum computers, do you see prices go down
prices will go down. Prices will go down, and it will be completely commoditized. Like the way we are like talking about AI is now something special and part of the hype cycle. But it will be as normal as electricity soon. For instance, take the Espressif ESP32 chip, which is a chip which costs a few dollars, which has Bluetooth, Wi-Fi, it has multiple cores, it can do pretty advanced calculations, it can do face recognition. You can now buy a smart camera based on this chip, and it's just a few dollars. I mean, imagine that it will go down in price even more, and it's just everywhere. It will be in TL tubes, it will be in this wooden table even. So what we will see is everything smart.
That's quite an exciting future. I guess that also raises some privacy concerns there if everything becomes smart. And how do you look at that? Well, are you concerned at all, or?
Yes, I am. I mean, I am concerned about my privacy and about the future evolutions about it. But I think that there is another technology that will have a breakthrough soon, called the blockchain, which will solve a lot of these issues.
You believe the blockchain will solve your privacy issues?
Yes, we're talking with multinationals, very big multinationals that you know, to combine blockchain and deep learning to make sure that people that are involved in clinical studies, for instance, have a mathematical security that their data is only used where they choose that it will be used.
Yeah. Okay. Can you explain how that will work exactly then?
Well, imagine that for a neural network, even for us, if we have 100 images of a new species, and we look at these 100 images, and then we can find that species ourselves in the wild. We can find an undiscovered animal in Sumatra or something.
Yeah.
That's how deep learning works, and that's how we work ourselves. We just have examples, and then we just absorb the knowledge, and we don't need these examples any longer to just apply that knowledge.
Mm-hmm. Mm-hmm.
And I lost my thread now, but
how the blockchain helps.
Yeah. Imagine that you just split an image, which are pixel values, with an arbitrary formula in two. So you have two noisy pictures, and if you add them up, it's just the normal picture.
Yeah.
That's how federated deep learning works. It's just does plenty of sophisticated stuff with the root data, so nobody can listen into the learning process and steal your data. You understand? So if you encrypt close enough to the agent, then you can not just download the data set of that agent.
Okay, all right. Not sure I fully understand, but I completely believe you if that's going to solve some privacy issues there. Maybe it brings us to the next topic of lessons learned. You've been in the field for quite a while now. I mean, you clearly had quite some successes. There must have been a few misses as well, both for you and your clients. Is there something we can share? Like, what are clients, when you go to clients for the first time, what are some of the things they consistently don't understand or get wrong about AI? Is there a pattern there?
Yeah, they believe in it too much.
Okay.
Many clients believe that it's magic. So, I mean, feet on the ground, it's not magic, it's advanced, it's mathematics on steroids. I mean, we are also mathematics on steroids, but very complicated and engineered by Darwinism. But what is important is that you start small, that you just start from a small success. I mean, the biggest failures in my career were when the ambitions were too huge too soon in the project, because then tension arises. Customer expectation levels, your own resources. So it's always important to cut a complicated thing into pieces and to come up with successes in short steps. Yeah. That's one of the big lessons learned.
Yeah, I really like that advice, because that's also the advice that we give to our clients. Is like, whatever you do it in small steps. Don't. I still see so many clients making these big 3-year long plans, and by the end of the 3 years, they will be in the nirvana or in the Valhalla, and it will deliver all the value at once.
Yes.
That has never ever happened. It's always it's good that you have a great vision, because you should have a vision of where you want to take your company and how do you want to serve your customers. But then knowing that vision and knowing where we are today, what is the next step, right? That is a super important one.
And think partnerships. That's also a lesson learned. Far too often we meet customers that want to solve all their problems themselves because they believe that they can own all the IP and so on and stuff. But this market is moving so fast that it's only to the companies that are open to smart partnerships to keep up the pace of this fast-moving market.
Again, I really don't want to just blindly echo what you say, but that's exactly my experience as well. I do understand where these clients come from, because let's be honest, you also have plenty of, let's say, consultancies or whatever you want to call them, that come in and they really just want to sell a whole bunch of crap to clients without educating the clients, or without helping the clients, or without bringing them to the next level. They just want to sell their product and be out again. Right? And in the end, the client, when the partner leaves again, the client's like, what did we gain exactly from this exchange?
Yes.
Well, I think it's super important, and I guess you guys are doing that as well. When you come into a client, it's not just delivering the project, it's also educating the clients, right? It's bringing them to the next level. Right?
That brings me to the third advice.
Okay.
Sometimes your client is expert in a field, but has hidden inconsistencies in his expertise.
Okay.
Meaning that, for instance, if you have to grade the quality of wood, for instance, of this wood. If you have 4 experts that tell something different about this quality, you will end up with something fairly inconsistent.
Of course.
But it will not be apparent, because if you look at these people once after another, if you do a batch, it makes sense. But if you bring together inconsistencies, you get an inconsistent model.
And I guess your solutions sometimes show those inconsistencies or discover those inconsistencies. I'm blanking out on the word here, but they just lay them bare or whatever. Aren't some clients then threatened by what you bring? Because,
of course,
are you challenging my expertise?
Yes,
I've been in this wood making business for 10 years and you,
exactly.
Mr.
It leads to tensions, because you try to be really rigorous and hard, but then these experts are not always having availability to do boring jobs like labeling data, and then it comes only apparent at the presentation of your results. You understand?
Yeah. And how do you deal with that tension?
Well, we try to be as transparent as possible and explain it while the project is moving on, but sometimes it's challenging. I mean, we haven't solved that issue yet.
Okay, cool. And so maybe to wrap up, looking forward for you and the company and the field, what are your ambitions for the next year? What do you hope to achieve?
Really to consolidate this platform as a reference platform for the value proposition we bring, this whole customer journey in deep learning, onto these large ecosystems of our partners, Google Cloud, Azure, Microsoft, NVIDIA, on-prem. That's our ambition.
Bring all of these things together, then you mean?
Yes.
Yes. All right, cool. That's a brave ambition. Well, Jonathan, our time is up. Thank you very much for sharing your insights. I learned a lot today, so I hope some of the viewers did as well. And we'll definitely see each other around.
Yes, Chris, thank you very much. Yeah.
Thank you, man.